Okay, we have a typical free body diagram here where we're going to be calculating acceleration. So let's start off by saying what do we mean by free body diagram? Well, a free body is really an isolated body, which means that we're just talking about one object. So we're going to say that this is our object right here, rather than saying that it's a mug on top of a table and all the other objects that might be in contact with it. We're just going to look at that one object by itself. So in this case, this object has a mass of 5 kilograms, and we want to know what is the net force. That's the first thing we got to figure out. So a net force is a result of all the component forces. So for example, in this case, going up here we have a force of 20 newtons, and down here we have a force of 20 newtons. These are two component forces. So in the up-down axis, we have 20 and 20. Those forces balance. This object is not going to be accelerating up or down. However, we can also look at this in the left-right axis, and to the left we have a component force of 40 newtons, and to the right we have a component force of 15 newtons. So we have an unbalanced pair here, which means that this object is going to be accelerating. So to figure out how much it's going to be accelerating, we're going to say number 1 minus our component number 2 is going to equal our net force. Incidentally, if we had another arrow coming off in the same direction, then we would add those two together, because if you think of it like tug of war, they'd both be pulling in that same direction. But that's not the case here, and I don't want to confuse you. So we're going to be subtracting. It tells us that our component 1, it could be the 40 or the 15. Let's make it the 40 newtons. And the component 2 is 15 newtons. And if you subtract these two, 40 minus 15 is 25 newtons. So that's our net force. So that's the first part of this problem. Now the second part is we want to actually figure out the acceleration. Now if you remember our triangle, you cover up the thing that we're looking for. In this case, we have force, mass, and acceleration. We're looking for acceleration. So our equation is force divided by mass. So we have A equals F over M. Now that force, remember, is our net force. So now we're going to plug in our values as our next step. Our net force we calculated was 25 newtons. And our mass, it tells us right up here, our mass is 5 kilograms. Now the only thing that can get a little tricky about these units is that we don't want to use newtons right now. And we said before that 1 newton is the same as a kilogram times a meter divided by a second squared. And that is always going to be the case. So instead of saying newtons here, I'm going to change the units to kilogram meter per second squared. And when I go on my next line, I'm going to solve with algebra. 25 divided by 5 is 5. Kilograms and kilograms is going to cancel. And then what we're left with is meters per second squared. So we have 5 meters per second squared. Now the last thing we have to do with an acceleration is we have to say what direction. Now up here, this object, the net force, is going to the left. And so in our answer, our acceleration, we need to make sure that we say it's going to the left. And that is how you solve the free body diagram problems where you're calculating acceleration.